Sir, now can you please tell us what is your role in planning the future missions, especially those projects which hold a significant scientific promise?
As I just mentioned, the upcoming missions, so Chandrayaan-4, which is going to be a sample return mission, where our idea is to land onto the lunar surface, collect the samples from the surface and beneath the surface. But ultimately the idea is to bring soil back to the India and do analysis thoroughly in the labs. Similarly, we have another mission called Chandrayaan-5, which is a ISRO JAXA mission, where the idea is to go into the polar regions, into a permanently shadowed regions, which we call a PSR, which never see the sunlight. Essentially because moon, as it goes around the earth, it is almost vertical.
It is a great honor and privilege to welcome a highly esteemed personality with us on the campus today, Professor Anil Bhardwaj sir. He is the director of Physical Research Laboratory, Ahmedabad, which is a pioneer institute in the space and scientific research. On behalf of Parul University, we would like to extend a very warm welcome to you, sir. And we are deeply grateful for your presence here today with us.
Thank you.
So we welcome you to this podcast series of Meet the Leader, which is our Parul University series. To begin with the series, I would like to ask you, sir, कि क्या आप हमें आपकी academic journey की starting में ले जा सकते हैं, wherein why did you pursue this career into planetary and space sciences?
Okay, so I have to recall my childhood days. मैं जब छोटा था तो हम लोग क्रिकेट खेलने जाते थे और कई बार ऐसा होता था क्रिकेट खेलते खेलते शाम हो जाती थी एंड देन मून यूज्ड टू कम अप एंड देन आई यूज्ड टू सी एट द मून एंड आई यूज्ड टू सी दैट यू नो द ब्लैक डॉट्स एंड डार्क पैचेस ऑन द मून. ऐसे भी काला काला धब्बा क्यों दिखता है मेरे को. और जब भी आप 4 महीने 6 महीने बाद भी देखे मून पे वही ब्लैक स्पॉट्स दिखाई पड़ते थे आपको. तो यूज्ड टू बी लिटिल क्यूरियस. उसमें मैं आई थिंक फर्स्ट सेकंड ग्रेड में रहा हूँगा. तो उतना हमारे ज़माने में इतना इंटरनेट वगैरह नहीं था कि यू कैन फाइंड आउट कि भाई क्यों ऐसा होता है. बट देन आई स्टार्टेड ग्रोइंग अप. आई स्टार्टेड लर्निंग अबाउट द मून, अबाउट द डिफरेंट प्लैनेट्स इन आवर सोलर सिस्टम. एंड देन आफ्टर आई स्टार्टेड डूइंग माई हाई स्कूल एंड +2 आई गॉट इंटरेस्ट इनटू इलेक्ट्रॉनिक्स. सो मेरा ये था कि आई शुड मेक माई ओन रेडियो और ट्रांजिस्टर, उस ज़माने में बोलते थे. And during that time, this was period of 1986, 85, 86, there was a visit of Comet Halley. And that was coming back into the solar system close to the sun. It was visible in the sky using your own eyes. And it comes after once in 76 years. So it's a once in lifetime opportunity. That made me a lot of interest into exploring the planets in the solar system, bodies in the solar system. And therefore, after completing my MSc in physics, I said I will do my research in these kind of objects, and that led me into planetary science. So this is how my journey has been in the initial period.
Okay. So now you have been involved in various pivotal missions like Chandrayaan, Mangalyaan, etc. So can you please share with us some scientific breakthroughs that you have seen in it? And what was India's growing role into deep space explorations into these missions?
Well, I was in Vikram Sarabhai Space Center since 1993. And as we had the success of the PSLVs, the launch vehicles and spacecraft being launched using our own rockets from our own soil, and ISRO started thinking about that can we have mission to the moon. And there was a lot of discussion going around in 1990s about whether India can undertake a mission to the moon. And I still remember around 2000 in the new millennium there was a meeting called in ISRO headquarters about whether India should have a mission to the moon. And there was a lot of interest among the scientific community to undertake that. And this was a time when I was already continuing in the area of planetary sciences. So I started jumping very well that, oh, now this is the right time for me to get involved directly into any mission being planned within the country for exploring the planets. And of course, the moon is the nearest celestial body. So I got involved into Chandrayaan-1 mission. We had an instrument on Chandrayaan-1 called SARA. And this was a very unique instrument being sent for the first time to explore the moon, to study how the solar wind, which is a wind coming from the sun consisting of largely protons and electrons, interacts with a body like moon which doesn't have an atmosphere and any intrinsic magnetic field. And that's how my journey into various planetary missions of India started. Subsequent to that, we had a mission to Mars called Mars Orbiter Mission, or Mangalyaan in short, and there also I had sent an instrument called MENCA, which is for studying the upper atmosphere or exosphere of the moon. And subsequent to that, I got involved into Chandrayaan-2 and Chandrayaan-3 and Aditya-1 mission. But I should say that the biggest discovery of the Chandrayaan-1 mission was discovery of water on the moon. And on the other side, we also came to know for the first time how this plasma wind which is coming from the sun interacts with the moon. On the other hand, using Chandrayaan-2, we have understood now that how the water distribution is there on the lunar surface. We have also learned a lot about various minerals present on the lunar surface. And when we talk about Chandrayaan-3, which is of course a very famous mission from India just 2 years back, which has made India the first country in the world to land into the southern polar regions, and also to give us a lot of new information, in situ observations about the moon, which is not present there. So it is changing our thought process about how the moon got evolved, what is the composition of the moon, how moon has passed through its period of evolution over the last 4.5 billion years, and what do we expect in the future, because exploration of moon is going to continue, and these missions, a series of missions, is going to help us in the Chandrayaan-4 and Chandrayaan-5 missions. So there have been a lot of discoveries which has happened through these missions, and I believe that this is going to help us understand the moon better, but also when we talk about exploring the moon in a better way, these results are going to be very, very useful for all of us.
Yes, sir. Sir, now can you please tell us, like, what is your role in planning the future missions going on at SPL and DSSC? And if you can please give us some glimpses into the current and upcoming projects at PRL, and like especially those projects which, according to you, hold a significant scientific promise.
So I'm currently at PRL, where my main job is to look at the future planetary missions of India, what kind of science we can do. And as I just mentioned, the upcoming missions, so Chandrayaan-4, which is going to be a sample return mission, where our idea is to land onto the lunar surface, collect the samples from the surface and beneath the surface up to a depth of probably 1 to 2 meters, and then bring it back to the Earth. And there's a series of complex maneuvers which has to be conducted when you do this kind of complex missions. But ultimately the idea is to bring soil back to the India and do analysis thoroughly in the labs. And that too from a region which has not been explored so far. And therefore it's a very exciting mission where we are truly excited about looking at those pristine samples which is going to come from the moon and make us understand something new about the moon. Similarly, we have another mission called Chandrayaan-5, which is a ISRO JAXA mission, where the idea is to go into the polar regions, into a permanently shadowed regions, which we call as PSR, which never see the sunlight. Essentially because moon, as it goes around the Earth, it is almost vertical. So if you have craters in the polar region of the moon, they will never see the sunlight. And that's why they become like a deep freeze. So temperatures are very, very low. So any volatiles, including water, if it is there, it will be sitting there for ages. And our idea with the Chandrayaan-5 mission is to go into those deep permanently shadowed regions and probe and see what material is existing there. Because if we have to put humans on the moon and a habitat on the moon, we need water. And therefore we should know where it is, how much it is, and how we can exploit it. And therefore these kind of missions are going to be very, very useful for future science as well as humanity.
Wow, sir. That's really great news to hear. So now you have received many prestigious recognitions such as Shanti Swarup Bhatnagar Prize, Infosys Prize, then Vikram Sarabhai Medal of COSPER. So how do such accolades reflect on India's scientific capabilities on a global platform?
Well, these are a part of a scientist's journey. As you progress and you make new discoveries or you bring out new science, you get honored through these kind of awards. But it also reflects that yes, the work which is being carried out within the country is of very significant and very important. And it also reflects on the capability of the country in the international scenarios, because all these missions which I just mentioned, like Chandrayaan 1, 2 and 3, they have been highly appraised by the international community, and the science outcome from these missions have been very interesting, very exciting, and scientific community around the globe has taken notice of these kind of science results, and therefore it gives you happiness also as a scientist that yes, our work is being recognized.
Right, sir. So now, as the founding president of IPSA, what are your key priorities for strengthening the India's planetary science research community?
IPSA stands for Indian Planetary Science Association.
Yes.
This is a new association which has been formed a couple of years back, essentially to grow the planetary science community as well as to spread this message about planetary science and exploration across India, not just among the scientists but also among the students.
Okay.
And the basic idea is to promote planetary science through conferences, through workshops, through training programs, and to help the students who are aspiring or are interested to do research in the area of planetary sciences, and what are the avenues which is available to them, how do they can or where they can go to do research. So this is a part of the activities which Indian Planetary Science Association is taking, so that we can grow the community, because we need more and more scientists in this area in the country.
Okay. So now, if you have to give one piece of advice to students who want, who are aspiring to contribute in some way to planetary science and space missions, then what would that advice be, sir?
So they have to excel in any field which they are interested, because planetary and space science also require various domains of sciences, whether it is a person in physics or chemistry or mathematics or geology or geophysics, or even in the area of exploration. It's an interdisciplinary field. So if you are a geologist on Earth, you can do geology of Mars or of Moon. If you are an atmospheric scientist on Earth, you can do atmospheric science on Mars or Venus, or on Jupiter, or even on comets. So it is just a small transformation which is required, but essentially any student who is aspiring to do planetary space sciences, his basic background with BS or MS or BTech should be in good grades and basic understanding of science. That is the core requirement.
Right. So we thank you so much for your valuable time that you have given us. And you have given, such a incredible explanation of your journey, and so many valuable insights that you have given us. So thank you so much, sir, for being here with us today.
Thank you. Thank you so much. Namaskar.